morning, one and all. My name is Kongpak Soonthornwan from grade 11C, and today I'll be presenting my IB Computer Science HL-AFL task, which the topic is comparing the number of characters needed in the Latin alphabet with those in Arabic and Asian language to understand the need for Unicode. Before we go into the need of Unicode, we must intellectually acknowledge about the historical timelines before the Unicode was established. Which ASCII, so-called as parent of Unicode, is the first globally introduced 7-bit standard encoding system for 128 English alphanumeric number and letters, which comprehensively included the small and capital alphabet letter, numerical digits from 0 to 9, basic punctuation symbols, as well as unprintable computer control characters, used in 1990 computer and telecommunication devices. ASCII values are sequentially represented in the tabular form via the 2-unit hexadecimal 00 to 7F and 7-bit binary numbers 7 zeros till 7 ones. A couple of years later, extended range 8-bit ASCII character sets at 1 byte or 8-bit can be run on a newer computer model, but it was being excessively implemented in various European languages, purposefully for accented signs and additional punctuation marks. Hence, there are too many code pages of extended character sets used in different technology organizations, such as Microsoft, IBM, Apple, ANSI, HP all use the different extended character sets without the internationally certified encoding medium. Then, all the tech firms experience difficulties to interpret correct alphabet characters, and linguistic incompatibility due to all extended character sets are dependent based on its own encoded platforms. As a result, it's highly likely to experience risk of computer performance corruption if encrypted data is transferred among the different operating systems in very portable devices. Henceforth, Unicode Consortium came in to play a major role in a significant change in Faculty of Computer Science, which all the tech conglomerates systematically troubleshoot the encoding issue by establishing the Unicode Transformations Format, so-called UTF-8. The primary objective of UTF-8 is to develop the versatile set of Unicode points that address all individual language alphabets, historical scripts, mathematical notation, and scientific symbols. The format convention rule is demonstrated with the letter U plus 4 following hexadecimal numbers for each Unicode character, ranging from 1 byte, 2 byte, 3 byte, and 4 byte, to beneficially maximize the total number of shortest possible sequence UTF-8 code points stored, which is up to 1.1 million character sets. In relevance with the presentation objective here, the UTF-8 code points for alphabet letters in BMP Asian language like Chinese, Japanese, and Korean is being allocated to 3-byte character groups, in contrary to 28 Arabic language characters or letters, which separately categorized into Arabic alphabets using 2-byte character group and Arabic presentation form A and B using 3-byte character group, whereas the Latin language characters are sufficiently stored within a 1-byte character group. With reference to the aforementioned UTF-8 explanation, we can distinguish the holistic difference between both that the Latin-based language like English, French, Spanish contain of 52 small and capital alphabet letters, numerical digits from 0 to 9, and basic punctuation symbols which could be officially represented by within available 256 bit character combinations. To be mentioned, UTF-8 Latin character format is backward compatible with ASCII's 8-bit sets. However, Asian language require more than tens of thousands code blocks of character combinations with intonations markers, and syntactic variations to satisfy the orthography requirement rules, including the CJKV Chinese, Japanese, Korean, Vietnamese Unified Ideograph Extension, which contains more than 75,000 in-use modern dictionary character sets, and for Arabic, approximately 2,000 character sets. For example, Chinese is divided into two main spoken types, excluding the dialects, which are Cantonese Chinese and Mandarin Chinese. Once more subdivided into two types which Microsoft IME Input Method Editor logically account as simplified Chinese and traditional Chinese scripts. Simplified is used in China and Singapore, and the traditional is used in Hong Kong, Macau, and Taiwan. Unlike English characters, which are differentiated with just vocabulary spellings as well as accent pronunciation, and remain mutually intelligible. Cantonese and Mandarin character combinations in ASCII and UTF-8 character sets are non-mutually intelligible. Also, their typographic arrangement must be encoded in different sub-Unicode character system, so-called as Guobiao for simplified Mandarin and Big 5 for traditional Cantonese. Same apply with the modern and traditional Arabic character combination block frameworks. Without Unicode encoding neutral system, it will be impossible to edit, type, read, interpret, and transfer the same online documentation with different global language characters. That's it, and thank you very much for your sincere attention.